Hey guys, this is Mr. Oliver again. This is going to be the solution to AP Physics 2, Unit 2, Practice Free Response question, and it's going to be for question number 2. All right, let's get going. So first of all, what we want to do, let's read the question real close, see what it says. All right, so we've got a piston cylinder arrangement once again with some gas in it. The height of that piston from the bottom is a height of h. The piston itself has got some kind of an area, so kind of an overhead view. You're looking at a cylinder, right? So it's just a cylinder shape, and the area of that circle is area A. Now, this is kind of an experiment question, so it gives us some data about temperature and the height of that gas. And so what we want to do is we want to first of all write a relationship between T and H in terms of the given quantities and fundamental constants. So whenever you see that, let's look at what it gives us. It gives us H, it gives us area A, it gives us pressure P, and it gives us temperature T. All right, and so those are all the given values. Oh yeah, there's also N number of moles. So whenever it says to write in terms of given quantities, that means that these terms are the only terms you can put in there, as well as fundamental constants. So fundamental constants would be things like G, or Boltzmann's constant, or vacuum permittivity, or something like that. All right, so let's go ahead and go and look at this first question. All right, so the first part, pretty easy because it tells us it's an ideal gas, right? So the ideal gas law says pressure times volume is equal to number of moles times the ideal gas constant times the temperature. So for part A, all I'm going to do is take this equation and rearrange and solve for N. So N just divided by RT, so I'll have pressure volume over RT. Okay. Now the thing is, they didn't give us volume, so I can't stop there. I need to look at the cylinder and determine what the volume of the gas is. Well, the volume of the gas is what's trapped inside that cylinder. Well, that cylinder has a height of h, okay, and an area of A. So to find the volume, it's just the area of that circle times the height of the cylinder, AH. That's just some old school geometry. And so I'm going to replace my volume with AH, and I'll have PAH over RT. And that's going to be my solution for part A. Okay. Part B says plot the data on the axes below so that you will be able to determine N from the relationship in part A. Label the axes with appropriate numbers to show the scale. All right, so whenever you see questions like this where it asks to graph something, what you should immediately think about is I need to find the slope of the line because that's going to tell me something. That's the best and truly the only way that they're asking on the College Board for these kind of questions. So what you want to do is look at your relationship, because that's what we're trying to find, is we're trying to find the number of moles. And yeah, I could pick out points, plug them into this equation, and with that data table they gave us and get some kind of average, but that's not what they're asking. They say to plot the data. So if you look at your graph, they give you a graph of height and temperature. Well, look at your equation. I've got height right here and temperature right here. And if you have this graph already set up for you, it's trying to clue you in that, oh, what is the slope of this line going to tell me? Well, the slope of that line will be the rise, or the change in the height, over the run, which is the change in the temperature. Well, if you look at your equation from part A, you have a height over temperature term right here. So that means that if I were to plot height over temperature and then multiply it by PA over R, that would give me the number of moles. In other words, I'm going to take the slope of this line that you graph, which is H over T, multiply it by pressure area over R, because those are all constants, that doesn't do anything, and that will allow me to find what the number of moles are. And so that's really all you're going to do, is you're going to take those numbers, plot them on this graph, draw a line of best fit, and find out what the slope is. Okay. So now part B, all it's asking you to do is label the axes with appropriate numbers, show to scale, plot your data points on here. And when you're doing this, guys, it doesn't have to be perfect, but what you do want to do is you want to make sure that the scaling is correct, the data points are basically where you need to put them. And so what I would do is just kind of look at your scale here, and it goes from 1.11 to 1.47. So it's okay to kind of break that up. Let's do one. I've got 5 data points, so I'm going to break it up into 5 increments. And so I would say like this would be like 1.0, 1.1, 1.2, 1.3, 1.4, 1.5. That's kind of the scaling I do. And on the horizontal axis, you can do something similar in terms of the temperature. So you could say like, let's say we start at 300, then go over here to 320, 340, 360, 380, 400, and I guess 420 would be the most. And guys, notice how I'm trying to use up as much of these axes as possible. That's generally what you want to try to do. And so then when you plot your points, they're not going to be perfect. You know, you start off kind of like there's going to be one there, I guess, and then the next one's at 325, so that'd be like around here. It's 3.29, so that's going to be like this. 320 or 1.19, I'm sorry. 1.19, so it's going to be like that. Then you're at 355, which is going to be right here. 1.29, so it's like that. Next one's at 375, which would be exactly right here. That's 1.37, so it's kind of like that. And then the last one, 1.47 at 405. So here's 400, 410, 405 is right there in the middle. And it's 1.47, so it's about up like that. Okay, so that's what it says. Plot the data on the axes and label the axes, and that's it. Now the next step in part C says use this graph and the values of A and P to determine what N is. And so this is where you're coming in and you're doing a line of best fit. And make sure when you're taking the test, guys, that you have a ruler handy, some kind of a straight edge. Because now what we want to do is we want to find the slope of that line. Now, doing it by hand is fine, but I found that by using a TI-84 calculator, if you have that available, it's really easy to do that stat plot function. And if you do the linear regression, linreg, you can get the slope pretty easy. I think when I did that, I got a slope of 0.00346 is my slope. And so now I can use this relationship for part C to find the number of moles. So N is the pressure times the area. Now the pressure is 1 atmosphere. So remember, you can't use atmospheres. You got to use the pascals version. So it's 101,300 pascals. That's one atmosphere times the area, and it tells us the area is 0.027. Then we've got the ideal gas constant on the bottom, which remember is 8.314. And guys, the constants are on the back of your equation page. You'll get to use that. Times the slope, which is 0.00346. And when you plug that into your calculator, you get 1.138 moles. That's your solution for part C. All right. Just a point breakout on this, guys. Part A was worth plus 2. Part B was worth 4 points just for graphing. Guys, take advantage of graphs if you get a question with graphs on it. And then part C is also worth plus 4. All right. So that's the solution for the second question. If you have any issues and need to ask me a question, just shoot me an email. Thanks a lot, guys. See you later.